طيب السلام عليكم شباب. طيب this is يعني a kind of replacement for the today class, as actually the class we were not able to record it properly. So last time in our first class, just to introduce to the internal combustion engine, we talk about the classification. Just I started actually with some terminology like gasoline engine, diesel engine. I told you what does it mean V8 engine, what does it mean turbocharger or supercharger, 4-stroke, 2-stroke, motorcycle. All of this yani just big terminologies, but actually all of this content actually or terminology will be discussed inshallah through this course. We'll go actually for all of this inshallah in details. Type last time also we said that we can classify the internal combustion engine as internal combustion, in which we burn as a fuel. Here we can just see we burn as a fuel here inside the engine, and we get the power from the same engine or the same place. That's why we call it internal combustion engine. In some other devices, we can classify them as external combustion, like in a steam power plant for electrical power generation. We use a steam turbine, but to use a steam turbine, we have to generate steam first. So we burn a fuel in the boiler in one device, in one location, burn as a fuel, generate heat. Then this heat is used actually to boil the steam. This is inside the boiler. Then we burn as a fuel in one location, and then we take this steam to generate power in another location or in another device actually, which is a steam turbine in this case. And in this case, we classify this combustion as external combustion because we burn in one location and we get the power in another location. We talk also about the advantage of internal combustion engines. They are of a small size, compact, they have high power per unit weight, and they have low initial cost actually, due to the massive production of internal combustion engine for the different application. But we have disadvantage of internal combustion engine, as the piston actually is reciprocating, then we can have a kind of vibration, and also internal combustion engine cannot be used actually to burn solid fuel, like the case of coal. We cannot burn actually coal or wood or something in internal combustion engine. Only they can burn liquid fuel. And in some modified engines, they can work actually for gaseous fuel like natural gas and hydrogen. And those kind of fuel are a little bit expensive compared to the solid fuel. We have different application for the internal combustion engine. As you know, we have automotive, railway station, we have the small aircraft, propeller aircraft, and also in the marine application, and also in ships and boats. Usually they use actually diesel engine for running actually those ships. And then we talk about the classification of the internal combustion engine from different actually aspects. We can classify them based on the application in automotive, light aircraft, marine, and so on. We can classify based on the engine design, reciprocating or rotary engine, like the Wankel rotary engine, which inshallah we'll be talking about. We can classify based on the arrangement of the cylinder. In one engine, we should have a number of cylinders. How we can arrange them? We can arrange them in line, vertical, V-type, radial. All of these are classification. And we can classify them actually also based on different other parameters that we have discussed as well. We talk also about the engine part, and we said the engine consists of the cylinder head, in which we have the intake valve, we have the exhaust valve, and in case of gasoline engine, we should have a spark plug to spark the combustion. Or in case of diesel engine, we can use actually the fuel injector, because the fuel is directly injected inside the cylinder. So instead of a spark plug, there will be a fuel injector in case of diesel engine. Then we have the middle part, which is the engine block, which contains the cylinder and also the piston inside this cylinder, which have a reciprocating motion. This reciprocating motion is connected actually to a connecting rod through pin. We have here the piston pin, and then it is connected to the crank pin. This is the connecting rod to convert the sliding motion or the reciprocating motion of the piston. It can connect it or convert it to a rotary motion through the shaft. And here is here is how the piston movement, the reciprocating piston is connected actually, is converted to a rotary motion through the crankshaft. And this is the crankshaft. You can see this is the crankshaft and this is the piston, and they are connected using the connecting rod to convert the reciprocating motion of the piston into a rotary motion of the crankshaft. Okay, we said we have counterbalancing weight here, while the rotation, in order actually to reduce the vibration within the system. We have seen this, all of this last time. So let's continue today. We said we have in the cylinder head, actually we have in the cylinder head we should have the intake valve and the exhaust valve, and those intake valve are operated actually using cam that are fixed actually to the camshaft. We have one camshaft for the intake valve to operate, open and close the intake valve, as you can see, and also we have another camshaft for the exhaust valve to open and close the exhaust valve. And then in the cylinder head, we have here is the spark plug. That means actually this is a gasoline engine. In case of diesel engine, we should have, instead of the spark plug, we should have a fuel injector. As you can see here also, these two camshafts are connected through a timing belt that is connected actually to the crankshaft in order to drive the two camshafts. In this case, Shabab, in some cases it can be laser belt, just a belt, and in this case it has to be replaced after almost 40,000 kilometers. We have to replace it because it is subjected to permanent elongation or something. But in case of a chain, solid one, metallic one, in this case actually this belt can actually work for longer, and it can be working actually in case of a chain for about 80,000 kilometers before the replacement. As I told you, Shabab, for this crankshaft, if we have 4-stroke engine, 4-stroke means actually we have 4-stroke movement of the piston from the top dead center, the top point, to the bottom dead center, and then actually this piston is reciprocating for 4-stroke for only one cycle. One cycle means, Shabab, starting from taking the fuel plus air until actually we have the exhaust of this after burning this fuel plus air. So first of all, the piston will be moving down in order to suck the air plus fuel. Then the piston will be moving up to compress air plus fuel. Then we have the spark, will initiate the spark to have the combustion. Then we can have the expansion stroke, which is the third stroke, and actually the fourth stroke is the exhaust stroke. So if we have 4-stroke, if the piston here, Shabab, you can look here. If the piston is moving down, that means the crankshaft will have rotated only half revolution. And when the piston actually moves up again, then it completes one revolution. So the crankshaft complete one revolution for 2-stroke movement of the piston. That means, Shabab, if we have the engine is working on a 4-stroke cycle, that means actually for one cycle, the crankshaft will be rotating actually 2 revolutions. But only, Shabab, for this 4-stroke, for one cycle, this camshaft actually should open the intake valve only one time, and also the other camshaft should actually open the exhaust valve one time during this cycle, during the 4-stroke. That means actually during the 4-stroke, this camshaft should be rotating only 1 revolution. So 1 revolution for the camshaft, 2 revolution actually for the crankshaft. That means the speed of the camshaft is actually half the speed actually of the crankshaft in case when we have a 4-stroke engine. In case the other case, if we have 2-stroke engine, that means actually the speed of the camshaft should be the same as the speed of the crankshaft. And that's why here, Shabab, for the case of 4-stroke engine, you can see the gear here, the size of the gear is actually double the size of the gear that is connected to the crankshaft. So that actually the speed here is half the speed of the camshaft, is about half of the speed of the crankshaft. And this is the function of the crankshaft and how it is connected to the crankshaft in order actually to operate the cam open, in order to open and close the intake and the exhaust valves. Type in the cylinder heat, also we have the intake and the exhaust manifold. The intake manifold, we have one common tube here, which actually takes the air, the fresh incoming air is coming in. And then the function of the intake manifold looks like a tree. Its function actually is to distribute this air equally to all of the cylinder. So its design, Shabab, is a little bit sensitive. We have to take care that in this design that each cylinder should be receiving the same amount of air. Because if we have one cylinder that is receiving actually excessive or more amount of air than the other cylinder, that means more fuel will be injected inside this cylinder, and that means actually this piston or this cylinder will result actually in higher power compared to the other cylinder. But actually the other cylinder, all of them actually are connected to the same crankshaft. That means there will be actually imbalance in this crankshaft, and in some severe situations this crankshaft actually may be destroyed due to unequal distribution of the air among the cylinder. Also, we have attached to the cylinder head, we have the exhaust manifold, which collects the exhaust gas actually from the different cylinder, and then it can exhaust it actually through the exhaust system to the atmosphere. The fuel injector, the function of the fuel injector, it is very sensitive to very important actually component actually for the internal combustion engine. In case of gasoline engine, usually this fuel injector is fixed upstream of the intake valve. So the fuel is injected in the intake manifold upstream of the intake valve. It should be injected at a pressure between 3 and 15 bar in order actually to atomize the fuel to precise droplet size, and that can actually spread over an angle. And those droplets should be actually very fine droplets so that it can actually mix with air properly, and then actually it can burn properly as well. Because fuel can never burn in the liquid phase. It has to be vaporized. That's why we have to increase the injection pressure a little bit in order to be able to atomize the fuel so that it can mix with the air and it can burn properly in this case. Otherwise, you can look here. This is a kind of dirty injector. After a kind of 80,000 kilometer, this injector actually become a little bit dirty and it needs to be cleaned, or in some severe situation it should be replaced, totally replaced in this case. And this is the difference here. This is the save of the injection batter after 80 kilometer from a dirty injector compared to actually the cleaned one. So this one will result in a big droplet size, and this may result actually in condensation of the liquid fuel in the intake manifold. So fuel may be condensate here, and once the intake valve opens, then in this case this fuel will just fall inside the cylinder in the liquid form. Due to the pressure and high temperature during the compression stroke, this fuel will be evaporated, but actually it will not have much time actually to mix with air, and actually this combustion of the fuel will not be complete combustion, and we will have actually, this is a kind of power loss, and also it will result also in engine emission. It will increase the engine emission in this case. So fuel is hydrocarbon, so if carbon is not completely burned with oxygen, so it will result in, instead of carbon dioxide, it will result in carbon monoxide, which is a toxic gas. And this is the function of the fuel injector. If you look at the design of the fuel injector, it is a solenoid valve, kind of solenoid valve. We have a magnetic field, so when the electric current is connected to this actually magnetic coil, it will generate a magnetic field and it will act as a magnet. So this magnet will absorb the middle plunger, it will release it from its base, and it will allow fuel to be injected upstream of the fuel, upstream actually of the intake valve. This is in case of gasoline engine. Otherwise, in case of diesel engine, the fuel will be directly injected inside the cylinder. And also it is the same design. The main difference, Shabab, is that in case of diesel engine, the injection pressure is much higher than the case of gasoline engine. But it is the same concept of operation. We have solenoid valve, magnetic field is created so that it can absorb the plunger, release it from its base, then the fuel is injected in this case. When the electric current is cut to the valve, then in this case the magnetic field will be collapsed and the plunger will sit on the fuel exit, and in this case it will stop injecting the fuel in this case. But why, Shabab, the injection pressure in case of diesel engine is much higher than the injection pressure in case of gasoline engine? This is related to the design of the two engines. In case of gasoline engine, the charge that is actually crossing the intake valve is a mixture of air plus fuel. Fuel is injected upstream here in the intake manifold. Almost the pressure in the intake manifold is atmospheric pressure. So in this case, we don't need much pressure actually for the fuel to be injected, because we inject the fuel in a low pressure medium. Secondly, actually, in case of gasoline engine, this fuel will mix with air, and it have enough time for mixing with air during the intake stroke while the piston is moving down, and also during the compression stroke. So they have enough time to be mixed with the air, then the spark plug can initiate the combustion process. But for the case of diesel engine, only the charge that is coming through the intake valve is only air. So we just, the piston suck the air during the intake stroke, then it compresses this air, and at the end of the compression stroke, we just inject the fuel. At the end of the compression stroke, the pressure inside the cylinder is very high in this case. So when we inject the fuel, it has to be injected at even at higher pressure, so that we can atomize this fuel. And also, secondly, this fuel, once it is injected, in the case of diesel engine, it is required immediately to start combustion, start mixing with air and start the combustion process. There is no time actually for much delay for starting the combustion. But unlike the case of gasoline engine, the fuel has much time during the intake stroke and the compression stroke to mix with the air. But in case of diesel, just by the end of compression stroke, there is a little time actually for this fuel to mix with air, and it has to start the combustion directly. So in this case, it has to be injected at very high pressure to make sure actually that the fuel is injected in a very fine droplet, so it can mix directly with air and it can start the combustion directly in this case. Okay. Here is the spark plug, شباب. The idea of the spark plug, it just receives the volt from the battery, and then this volt actually is posted actually inside the ignition coil, which posts the battery volt, which is around 12 volt. This volt is posted actually through the ignition coil in the ignition system to 15,000 volt. Then we can supply this volt to the required cylinder based on the firing order. And we'll have here a volt here connected to one side of the spark plug of 15,000 volt, and the other side, the other terminal here actually, شباب, of the spark plug will be connected to the engine body, which is the air connection. Once we have this high voltage potential, then the air between actually the two terminal can be ionized, and in this case a spark can be generated within the cylinder and the combustion can start in this case. So this is an example how the spark plug look like, which is used actually in the internal combustion engine. So the idea is to generate high volt in one terminal, and then the air can be ionized between both of them, then we can initiate the spark. When designing an engine, the engine, as I told you, is designed in three main parts. The middle part, which is the engine block, which hosts actually the cylinder, and inside the cylinder we have the piston, and here we have also the cooling water circuit, the cooling water coming in and the cooling water that is leaving. We have a water jacket around this cylinder, and also in the engine block we have the opening also for the lubrication oil, which lubricate actually the outer part of the cylinder, and also it lubricates actually the cylinder, the piston heat itself inside this cylinder. And also we have, this is regarding actually the engine, the lubrication in the engine block. Actually, any moving part inside the internal combustion engine has to be lubricated using the lubrication oil. Here is the other part, the top part of the engine, which is the cylinder head. Cylinder head consists actually, it is attached to the top part of the engine block, and it hosts actually the intake and the exhaust valve. Here we have intake valve, and we have as well actually exhaust valve. In this engine, this is a kind of heavy-duty engine. We have two intake valves within the system, and we have also two exhaust valves. And in between here in the middle, we have a spark plug in case of gasoline engine, and in case of diesel engine, instead of the spark plug, we have the fuel injector. Also, it hosts a spark plug, as we said, for gasoline engine, and fuel injector for diesel engine. And also at this cylinder head is attached actually to the intake and the exhaust manifold as well. The lower part of the engine, شباب, which is the lower cover of the engine, this lower part we call it the crankcase or oil sump, which is attached actually to the lower part of the engine. Inside this شباب crankcase, it hosts actually the oil pump and the oil filter, and also all of the oil that is dropping from the engine is just accumulated here inside this oil sump. And this counterbalancing weight, شباب, while rotating, while the crankshaft is rotating, it just immersed inside the oil, inside the crankcase, and it splashes the oil everywhere actually to just lubricate the crankshaft. And this piston, شباب, is hollow from inside, so the splashed actually oil also can lubricate the inner part actually of the piston in order to cool down its temperature. So those are the three main parts of the internal combustion engine. We have engine cylinder head, we have engine block at the middle, and the lower part we have the crankcase. Here are actually, in addition to the engine itself, we have some auxiliary unit. We have the fuel circuit, which contain actually the fuel filter, the transfer line, and the fuel pump. Fuel pump is immersed in the fuel tank, so that actually we don't have air around this fuel pump to prevent the ignition for any reason, because this fuel pump is connected to an electric motor to drive it, and we should have electrical tunnels. So there is a possibility actually to have a spark from at any part of the fuel pump. So if there is a spark and we have fuel, and if this fuel pump is subjected to air, so actually explosion or combustion may start at any time. To prevent all of this, we have to immerse the fuel pump inside the fuel tank. So to start ya shabab combustion, we have to have oxidizer, which is air, we have to have fuel, and we have to have a spark. For the fuel pump, spark can start any time due to the electric current to the electric motor, and also we have fuel, so what is missing is the air. So if we have air, so actually this fuel pump may fire at any time. So we just immerse it inside the fuel to prevent actually having this fuel pump initiating any sort of fire at any time. It also delivers the fuel to the fuel injector. And we have actually a complete fuel injection system for the gasoline engine, which is controlled actually through what's called the electronic control unit, which acts as the brain of the engine. We have also shabab the oil circuit, which contains the oil filter and the oil pump. We said oil filter and oil pump, they are just hosted inside the crankcase at the lower or the bottom part of the engine. And it actually circulates over to all of the moving part of the engine, including piston, crankshaft, cylinder head, camshaft, valve, cylinder head, including the rotating camshaft, and also the valve. So any part that is already moving, any kind of mechanical movement, this part actually should be lubricated using the lubrication oil. In addition to the lubrication oil, shabab, to control the temperature and reduce friction, we have the cooling water circuit. Cooling water circuit, the idea we have a cooling water pump, so that we can actually take this cooling water and it circulates actually around the cylinder. There is a cooling water jacket around all cylinders. Then it will cool down actually the cylinder material to prevent actually excessive heating, and the water will be heated up a little bit. So in this case, we have a thermostatic valve depending on actually the water temperature. If the water temperature is high, that means actually we have to apply more cooling to the system. So we have to pass actually more water around the engine. So this is a thermostatic valve. So depending on the temperature, if the temperature is high, it will be actually widely opened in order to allow more water to cool down the engine. If the temperature is low, then in this case it will actually partially opened in order to reduce the amount of the flow rate of water in this case. Because shabab, excessive cooling of the system will result actually in losing part of the heat of the system. So part of the generated heat due to combustion will be absorbed by the cooling water. So excessive cooling is not good as well, like also the excessive heating. So this is the thermostatic valve. So the hot water will be passed through the radiator, which is the front part of the engine in the car. And here actually we have a fan. The fan will draw the air to be passed through the radiator in order to cool down the water, and then the pump can recirculate actually this water back. Usually if this internal combustion engine is inside the car or something, so the case is much easier because the car is already running at high speed and the air is already forced to go inside through the radiator with the same speed. That's why if the car is running over actually a high road or something, so the cooling process will be actually much more effective than the car if the car actually is moving at low speed. Because moving at low speed, the air velocity will be reduced, and in this case the fan has to be running and it consumes part of the crankshaft power. It has to be running in this case in order to draw the air if the engine is running at low speed. This is a cooling water circuit. Also, we have the intake air system. We have the intake that contains the air filter, and we have the throttle valve. Throttle valve is the mean by which actually the flow of air is controlled to the gasoline engine. So if you are just sitting in front of the wheel in your car, if this is actually a cylinder of the engine, and those are the oil ring, this piston is connected to the crankshaft, and the crankshaft here is rotating. Here we have the intake valve, which is connected to the intake manifold, and here we have the exhaust valve, where it is actually connected to the exhaust manifold. In the intake manifold here, we have the fuel injector. Is fixed actually in case of a spark ignition engine. We have here spark plug in case of a spark ignition engine, and we have the fuel injector is just fixed upstream of the intake valve. Here, what is coming here to the engine, air is drawn, and actually it is introduced through the intake manifold to the engine. But to control actually the amount, the power of the engine, here we have a throttle valve. This is a kind of valve. This valve is connected to the accelerator pedal, which is just if you are sitting here in your car, so you are just sitting here, and you are just pressing the accelerator pedal under your leg. So this accelerator pedal is connected to the throttle valve. So this is the throttle valve, which controls the amount of air that is drawn inside the engine. So based on your press and the accelerator pedal, this throttle valve will be open. If you press more the accelerator pedal, this throttle valve actually will be just fully open to allow all of the air to coming into the system under the full load condition. So the amount of air is already measured so that we can calculate the mass flow rate of air. And based on this, actually, the electronic control unit calculates the amount of the fuel that is being injected. Then we have a mixture of air plus fuel is drawn inside this cylinder. So in case of gasoline engine, the amount, the load is controlled actually through the throttle valve. The accelerator pedal under your leg is just connected to the throttle valve in order to control the amount of air. Unlike the case of diesel engine, we don't have a throttle valve. The accelerator pedal is controlling actually the amount of fuel, not the amount of air. So it is connected to the fuel pump, and based on your press, this part of the fuel actually pressurized by the fuel pump is just recirculated back to the fuel tank. So if you press the accelerator pedal in diesel engine much high, if you just press much actually the accelerator pedal, that means we need high speed, we need high load. That means actually a small portion of the compressed fuel by the fuel pump will be actually returned back to the fuel tank, and most of the fuel will be going and injected inside the cylinder. So the accelerator pedal in case of diesel engine controls the amount of fuel, but the accelerator pedal in case of gasoline engine, it controls the amount of air through the throttle valve, and this is what we mean by the throttle valve, which control actually the engine. We have also the exhaust system, like what you can see here, which is connected to the connect actually all of the exhaust, leaving out actually all of the cylinder, connect them actually in one common exhaust manifold. Then we can exhaust all of the exhaust gases to the atmosphere. The function of the exhaust system. In many cars, actually, you will find there is a catalytic converter that is connected to this to the exhaust system of the car in order to reduce down the emission. The idea of the catalytic converter, we have the exhaust gases consists actually of CO, some CO2. We have NO. We may have also some NO2 because we are burning the fuel with air, and the air actually contains the nitrogen. So when burning, due to the high temperature, this nitrogen will be dissociated, and it will react with oxygen to create NO plus NO2. So the catalytic converter, it converts actually this CO, it have oxidation reaction, CO plus half O2, then it can convert it to CO2. This is a kind actually of toxic gas. So it oxidates the CO to complete its combustion, then it can convert it to CO2. Also, if we have unburned hydrocarbon of the fuel, it actually completely burns this hydrocarbon in order to be converted to CO2 plus H2O. Here we have H2O as well. But what about NO and NO2? These are called actually as the NOx emission, NO plus NO2. So the catalytic converter, it just make reaction in order to convert NO plus NO2 to convert them actually to N2 plus O2. So at the exhaust system here, finally we will have CO2 plus H2O plus, in this case, N2 plus O2 in this case. So the main function of the catalytic converter is just to reduce the emission in the exhaust system. Usually the exhaust system is made actually elongated, because once the exhaust valve open here, the pressure inside the cylinder is still high. And when it is open, this flow actually is subjected to the atmospheric pressure, which is a low pressure. So we have to extend this exhaust system in order actually to expand or reduce the pressure from the cylinder pressure once the exhaust valve open until we reach the atmospheric pressure. That's why the exhaust system is little bit elongated. Yani some guys actually just like to have a noise of his car. He comes actually into the exhaust manifold close to the engine, and he just make a small opening here. A small opening, this will be a kind of, it will create flow throttling. So we have high pressure here. Once the exhaust valve open, is created high pressure, and just outside this opening we have the pressure is atmospheric. So we have high pressure drop in this case through a short distance, so it will just create some noise. Yani some guys loves to have some noise out of his car while he's running, so he can do this. We have also شباب the clutch, which is the part that connects the engine to the drivetrain, to the wheels of the car, the gearbox, and from the gearbox to the wheel of the car. Clutch شباب, it's a function like if you are running the engine and the car is stopped. Is not moving, like in the parking mode or in the neutral mode. In this case, we have the clutch, which just separate or disconnect the engine from the drivetrain. Once you start driving on the driving mode, then the clutch actually will engage the piston, will engage actually the crankshaft with the drivetrain. Drivetrain, which is the gearbox, plus some other components. The gearbox actually is a box of different gears of different sizes. If I want the car to go with higher speed, then we can connect a small gear size to the crankshaft. Then we can have higher speed of the car, and it depends actually on the required speed that you need. You can actually just change. Actually, the gearbox is doing this function to give you the required speed of the car. It just play actually shabab with the RPM of the crankshaft. If we need actually a given speed, higher speed, I can actually connect the crankshaft to a smaller gear. If I need actually lower speed, then in this case the crankshaft can be connected to a big diameter gear. So it's a kind of gearbox of different gears to generate actually different speed of the car. The battery shabab, which is provide actually, first of all, it provides the electric current to start the engine. We have a startup motor which take its current actually from the battery to start the car. This is the startup motor. The idea shabab, if you are starting the battery, starting your car, and if it is not starting directly, that means there is a problem with the battery, and you should not try or continue pressing the starting switch, because continuous pressing actually of the starting switch will result actually you may kill the startup motor. Okay, so if the car is not starting properly, then in this case there is a problem with the battery and we have to replace it or something. Also the battery shabab, it provide the initial volt to be amplified through the ignition coil to the high voltage in order to drive the spark plug and generate the spark in the different cylinder in case of gasoline engine. And also the battery powers actually everything that run on electricity, like actually the lamps, lights, and some other actually component within the system. We have the alternator or the electric generator, or what you call actually the dynamo, which just recharges the battery from time to time, and they take part actually from the crankshaft power in order to work as a generator. In this case, we have shaft power input, then it can generate electrical power to just charge the battery. The spark coil, which as I told you, the ignition coil, which converts the battery volt from 12 volt up to actually 15,000 volt in order to trigger the spark inside the cylinder. The electronic control unit, which is a very important component of the internal combustion engine, which senses actually it have input, since all of the parameter inside the engine. It senses the engine speed, engine RPM, the crankshaft RPM, the exhaust emission, and also the pollutant sensor, and the gas brake pedal, and the gas and the brake pedal, actually the accelerator pedal, your pressing the accelerator pedal, it evaluates it. So just actually it can have an idea about the throttle valve opening here. Throttle valve, it decide about the load, and it has also the speed. Based on the load and the speed and the temperature of the air, it can calculate the amount of air. Then based on the required RPM and also the cooling water temperature and also the oil temperature, lubricating oil temperature, it can decide actually about the amount of fuel to be injected. In most of the modern engine, ya shabab, they are actually electronically controlled. The amount of fuel is calibrated based on actually the input from the electronic control unit. So any car manufacturer, ya shabab, when start manufacturing an engine, they just test this engine at all possible situations for all loads, all throttle valve opening, and also for all RPM. So at a given throttle valve position, based on the press on the accelerator pedal, and based on the required RPM, the electronic control unit determines actually the amount of fuel that has to be injected inside the cylinder, and also it decides about the spark timing, when we have to initiate the spark to initiate the combustion within the cylinder. Okay. These are the main component and the auxiliary component of an internal combustion engine. Here يعني is this is a kind of representation about the component of the engine and how we can connect them together. This is the engine block, shabab, in which we have the cylinder and the piston are connected to the engine block. The crankshaft, shabab, and this is the connecting rod. Then we have the piston, and this is actually the piston pin that connect actually the piston to the connecting rod. Flywheel, which actually reserve part of the power during the power stroke, then it can release actually during the other stroke in order to move the piston. So this shows the cylinder head, which should have the valve intake and the This is the camshaft, shabab, the camshaft for the intake valve and the camshaft. There is a gasket that separates actually the cylinder head from the engine block. This chain, shabab, which drive, as we said, the oil pump will be just fixed in the crankcase in the bottom part. It will drive actually this pump, and also there is another chain to drive the two camshaft through the connection with the crankcase, which is the lower part inside which you will have the oil pump and the oil filter, and this shabab opening inside which you will have a metallic strip that is connected to the top of the engine, This metallic strip measures the engine oil level inside the engine, inside the crankcase, which actually, if you have a car, there is a metallic strip that you can just pull it outside, and then you can look actually the oil level inside the crankcase. This is the opening, and you can see actually this metallic strip. It will be just connected right now. This is an intake manifold and the exhaust manifold also. Metallic strip that I'm talking about, which you can just pull it up in order to measure the level inside the crank, level of oil inside the crankcase. Then at the top, we can just fix the connection to the spark plug. Spark plug and their connection, and the fuel injector as well. Okay. This video just to show you how the engine is operating. We have the intake air is coming in, fuel is injected upstream of the intake valve in case of gasoline engine, and then actually piston is moving down to take the air plus fuel, and then it compresses it back during the compression stroke, and the spark plug will initiate the combustion. Then we can have the power stroke followed by the exhaust stroke. As you can see here, Shabab, this is the fuel injection. Fuel injector is just injected the fuel inside actually the intake manifold, the upstream of the intake valve. Then this fuel plus air will be just drawn inside the cylinder. Once the intake valve open, then this is at the middle. We have the spark plug to initiate the combustion by the end of the compression stroke. Okay, so that's all about the engine components. So let's look at some engine terminology, which we are using actually in the design of the engine or the specification of any internal combustion engine. So usually, Shabab, there are some terminology. We have the diameter of the piston inside the cylinder. We call it actually the piston, the bore of the engine, bore of the cylinder, bore which is the diameter of the piston. And we have the stroke movement, which is the distance between the top dead center and the bottom dead center inside the piston. So if we have a piston, this is a cylinder. Inside this cylinder we have the piston, and here we have the oil and the pressure ring at the top part of this piston. The diameter of this piston, we call it the bore of the engine. At the top here, we have the intake valve, and here actually we have the exhaust valve, and this is actually the intake valve. And here at the top, as you know, we have either a spark plug in case of gasoline engine, or we have actually a fuel injector in case of diesel engine. As the piston actually, as we have the combustion process, and this piston actually is connected to the crankshaft, and while the crankshaft motion, this piston actually is moving reciprocally from actually inside the cylinder, from the top dead center, the top point that the piston can reach inside the cylinder, we call it the top dead center, and the lowest point that the piston can reach, we call it actually as the bottom dead center. And the distance between the bottom dead center and the top dead center, we call it L, which is the stroke. So D, which is the diameter of the piston, we call it actually the engine bore or the cylinder bore or diameter, and actually L, the distance L, we call it actually the stroke of the piston. And the piston يا شباب and the volume displaced while the piston is moving from the bottom dead center to the top dead center or the reverse. This volume we call it the displacement or the stroke volume. Displacement or stroke volume. This volume is the volume of the cylinder, which is equal to the cross-sectional area multiplied by the height. So the displacement volume is equal to pi over 4 multiplied by the diameter square multiplied by the stroke. If we have an engine of a number of cylinders, then in this case we have to multiply by the number of cylinders Z. So Z is just representing the number of cylinders inside this engine. This is about what we call as the cubic capacity of the engine, or we call it actually the engine CC. So if you have a car or something, there is very important to speak of the car, which is called actually the cubic capacity or the engine CC. Engine CC is the displacement volume, the volume displaced by the piston inside a cylinder, single cylinder, multiplied by actually the number of cylinders of this engine. The volume of the gas, the volume inside the piston, that actually the volume inside the cylinder that the piston cannot reach, which is above the top dead center, we call it as actually as the clearance volume. And the total cylinder volume, the volume of the cylinder, will equal to the displacement volume plus the clearance volume. And this can be related to each other through what's called actually the compression ratio. So the RC, which is the engine compression ratio, which is the ratio between the volume of the cylinder divided by the clearance volume. The volume of the cylinder, which is the displacement volume, plus the clearance volume, all of this is divided by the clearance volume. And the total volume divided by the clearance volume gives us actually the definition of the compression ratio inside this engine. And this gives us indication about the maximum pressure inside the engine. So usually we have air plus fuel in case of gasoline engine are just drawn inside the piston while the piston is moving down. Then this air plus fuel will be just compressed, and the piston will be moving until it reaches actually the top dead center. By the end of the compression stroke, the pressure inside the cylinder in this case, it approaches actually the maximum value because the volume in this case has been compressed to the minimum volume in this case. So the compression ratio is a parameter that gives us indication about the maximum pressure inside the cylinder. And usually for a gasoline engine, this compression ratio parameter in case of gasoline engine, this value of compression ratio, it ranges from about 8 up to 10.5 or 11 at most. But the compression ratio in case of diesel engine, this compression ratio, it can range actually from 14 up to 22. So what does it mean, Shabab? We have a big difference between the gasoline engine and the diesel engine. The compression ratio in the diesel engine is much higher than that of the gasoline engine. But we said the compression ratio gives us indication about the maximum pressure inside the cylinder by the end of the compression stroke. So if the pressure inside the cylinder is higher in case of diesel engine, that means actually this piston can generate more power during the expansion stroke. That means actually the pressure, if the compression ratio is higher in diesel engine, that means the pressure inside the diesel engine is much greater than the pressure inside the cylinder in case of gasoline engine. And if we have higher pressure by the end of compression stroke, that means actually during the expansion stroke, the piston is expanding from higher pressure. That means it can generate higher power. That means actually the power in case of diesel engine is much greater than actually the power in case of gasoline engine. So that means you have the efficiency of the diesel engine, the efficiency of a diesel engine should be greater than the efficiency of a gasoline engine, and this is actually the case. The efficiency of the diesel engine should be actually greater than the efficiency of the gasoline engine. Okay. By what is the reason, Shabab? Why we can go for higher compression ratio in case of diesel engine, so that actually we can generate higher maximum pressure, and we can generate more power of the engine. But in case of gasoline engine, we cannot increase actually the compression ratio higher than 10.5. So actually we cannot reach higher maximum pressure. Because in case of gasoline engine, as we said, the charge in case of gasoline engine is air plus fuel. This air plus fuel is taken inside and then it is compressed. So if the compression ratio is high, that means the pressure here will be actually increased too much inside the cylinder while the piston during the compression stroke. That may result in self-ignition of the fuel. So in this case, in case of gasoline engine, if we increase the compression ratio, we may have self-ignition of the fuel, starting self-ignition here while the piston during the compression stroke, some self-ignition started here. It's a kind of explosion. And self-ignition started at this point, at this point, at this point, so it's a kind of successive explosion. This is what we call the engine knock. So the engine is knocking. There is a noise of the engine due to the self-ignition. So in case of gasoline engine, as the charge to the engine is air plus fuel, so while the piston is compressing this air plus fuel, we may have self-ignition if we have higher compression ratio. That's why we cannot use higher compression ratio in case of gasoline engine. But in case of diesel engine, the charge that is coming here is only air. And the fuel is injected from the injector inside the cylinder at the end of the compression stroke. If we have the charge is air, then we can compress the air to any pressure. And we can reduce actually the clearance volume in this case. And we can raise actually the compression ratio for the case of diesel engine. So that means the diesel engine is more efficient than the gasoline engine. But the question is, you can see the gasoline engine everywhere, but you cannot, you can see actually limited number of diesel engine, only in some heavy duty trucks or something, and in railway station, marine, in big engine or heavy duty engine. Why we are not using actually for too much if it is having already higher efficiency than the gasoline engine? So the reason is that for the diesel engine, fuel is injected at the end of the compression stroke. And in no time, we just need this fuel actually to mix with air and start burning, because we have expansion stroke. We have to have expansion stroke. You have to start the combustion of this fuel. So this fuel needs some time to mix with air, and then actually it can initiate the combustion. But if the engine speed here, the RPM of the engine, if it is too high, then in this case, the time for the fuel to burn completely will be reduced in this case, and it will result in incomplete combustion of the fuel, because there is no time for complete combustion. Just we need some time. Fuel is just injected, so it needs some time. But if the RPM is high, then in this case, great portion actually of the fuel will not be burned, and the engine power will be dropped in this case. So that means, in case of diesel engine, we cannot go for higher RPM, and that's why the speed of the car for diesel engine is little bit actually slower than the case of gasoline engine. And because actually of this, diesel engine cannot go for higher speed. In this case actually we prefer to go for the gasoline engine, because most of the people actually, they don't care about the efficiency, just they care actually about the speed of the car. Okay. Still, we will continue the classes till we have some time. This is all what we say. What about the configuration of the internal combustion engine? The configuration of the engine itself, it can be inline engine. We can just arrange the cylinder in line just beside each other. Usually they are 4-cylinder or 6-cylinder, but more than this we cannot consider the inline engine, because it will become actually so long. It is for 4 or 6-cylinder, it is less to go wrong. There is no possibility actually to go wrong through the crankshaft, and it is cost effective and narrow. But actually its disadvantage, it is just a limited number of cylinder. We cannot use many number of cylinder, as the length of the engine will get elongated, and it have higher center of gravity, and this may result in tilting or unbalancing of the engine. We have also the U engine, which we have two inline engine. Each one have a separate crankshaft. Then we can have actually connect the two crankshafts through actually a gear or something, or a chain. Then we can have a common crankshaft revolution at the outlet of this engine. We have also the V engine. V engine, we have two inline engine are arranged in the V shape. This is in case of SUV car, little bit heavier car or heavy duty engine. In this case, we can use two inline engine beside each other, taking the V shape. The angle of the V should be the inner angle, should be degree up to 90 degrees, 60 or 90, depending on the number of the cylinder. For higher number of cylinders, then in this case, we have to consider the 90 degree. Both of them are connected on the same crankshaft. We have also the W type, either W type or we have double V. All of this actually W type or double V, we have multiple inline engine are connected on the same crankshaft. Here, Shabab, we have so many number of cylinder can be inserted in this case, so that the power output actually is very high. This is actually highly heavy duty engine can be applied in this case. But actually, disadvantages, there is actually much more possibility for this crankshaft to go wrong because we have too many cylinders are connected on the same crankshaft. But it can provide actually huge power output. We have the H engine. H engine, which is the H design, we have two separate actually engine, flat engine. We have two crankshaft. Those two cylinders are connected to one crankshaft. The other two cylinders have another crankshaft, and both crankshafts are connected through gears. Then we can have actually one common outlet of the engine. This takes the shape actually of H shape. Also, we have the flat boxer engine like the one in Subaru. We have two straight actually banks of cylinder opposite to each other. This is horizontal engine at angle equal to 180 degrees C from either side of the crankshaft, and we have only one common crankshaft in this case. We have also a special case of internal combustion engine, which is the Wankel rotary engine. This is a kind of rotary engine. We have a rotor instead of piston. We have a rotor in this case. This rotor actually divides the combustion chamber into three zones. So we have three combustion chamber in this case. The rotor, Shabab, is a centric rotor. It is not concentric, it is a centric rotor. Only we have at the middle, if you look here, at the middle part, you will see here, this is the crankshaft, which we have actually a gear around. And we have actually this red gear. Red gear is connected to the rotor. The rotor itself is not concentric, it is eccentric, and it is rotating. So while this rotor is rotating, when it uncovers the intake port, we don't have valve, just we have port. When it uncovers actually the intake port, some fuel plus air will coming in, and then it will ignite it here, start the combustion, and then actually we can have the exhaust gases are leaving in this case. But only for one revolution, each one revolution, we have three combustion chamber, and that means actually we have three power pulses for only one revolution. That means this is a powerful engine. We have three power pulses because we have three combustion chamber for only one revolution of this rotor. This is a Shabab, you can see here. This is a suction stroke in which we take the air plus fuel, and then we can compress it to the minimum volume, which is the red part here, and then we can have the spark plug. In some cases, we use two spark plug in order actually to make the combustion process a little bit faster, and then we can have the combustion, and then the exhaust valve, the rotor uncovers the exhaust port, then we can have the exhaust gases are leaving, and then the cycle is repeated in this case. And we have cooling water jacket around the whole engine. This engine, Shabab, it have no valves. We have continuous combustion and we have an inlet port. We don't have reciprocating motion, so it is of less vibration, and it is compact, and it have high power per unit weight or per unit volume. It have high power because we have three combustion chamber. For each revolution, we have three combustion pulses. It has low compression. One of the drawbacks, it has low compression ratio because we cannot actually reduce the clearance volume or the minimum volume actually of the gases too much, so that actually it has low compression ratio. That means the pressure inside the cylinder at the minimum volume will not be that much. Due to also we having port, so once the combustion start, we have the exhaust port is already opened, uncovered. So some of the fuel can actually just just escape through this opening without completing the combustion. So the possibility of having unburned hydrocarbon is there, and also may have incomplete combustion of the fuel to have carbon monoxide. Also, it is subjected to some problem like sealing, leakage problem, and also due to actually this eccentric motion around the crankshaft, there is high friction actually is generated here, which requires special kind of lubrication, and excessive wear will be actually occurring after some time because one gear is rotating around the central gear, which is the crankshaft. But it has been applied in some car, like the Mazda RX-8 car. We have double rotor, double actually 1 kil rotary engine are connected to each other to have this car. Yeah, and this is a rare model, and it is not actually much used actually in the car. Type the spark ignition engine versus the compression ignition engine. As we have explained this more than one time, in case of gasoline engine or spark ignition engine, we have a spark plug, and the charge to the engine is a mixture of air plus fuel. And by the end of the compression stroke, we start the combustion through the spark plug. So it is a spark engine. We have the gasoline, which is the main fuel, or the octane. We call it octane with octane number 92, 95. When you go to the gas station, you can see this. Its chemical composition is C8H18. We can use also in some gasoline engine, we can use compressed natural gas. We can use ethanol, bioethanol, methanol. We can use hydrogen in spark ignition engine. We can use liquid petroleum gas or liquefied petroleum gas, which is a mixture of propane plus butane. This is the fuel that is used in the cylinder for cooking at homes, which is used actually in stoves and all of that. This is a liquid petroleum gas. It can be used in the gasoline engine, and also we can use actually some new fuel like the new synthetic fuel like the nitromethane, which is CH3 plus NO2. This is for the gasoline engine. As the system needs spark, so we have to have ignition system, and also we have the fuel is injected, then we have actually a fuel injection system, and this injection system in gasoline engine is completely different from the diesel engine. The injection system in case of diesel engine is completely depending on the design of the injection pump. We have two kinds of injection pump. We have kind of inline pump, and we have the distributor pump. This pump is connected to the accelerator pedal. The press on the pedal when you are driving the car, it decides actually about the amount of fuel that should be recirculated to the fuel tank and the amount of fuel that should go to the fuel injector to inject the fuel inside the cylinder. This is the fuel injection in the diesel engine. In case of gasoline engine, most of the gasoline engine has been converted to the electronic injection system. The most common one, or the most modern one, we call it actually the Motronic fuel injection system, in which actually the electronic control unit decide about the amount of fuel to be injected, depending on the engine load, the throttle valve position, and also the engine speed, and some other related parameter like the air temperature, cooling water temperature, oil temperature. Then it can decide about the amount of fuel to be injected. The component of the injection system itself, we have the fuel pump, fuel filter, then we have the line, and then actually we have the fuel injector at the end. And all of this system is controlled by the electronic control unit. So we have assigned those three topics. One topic for Motronic fuel injection system and the ignition system. And the third group will be just presenting on the diesel fuel injection system. You can just search and try to prepare us slide, show us the component of all of those system and the function of each component in all of these systems. In the ignition system, there are different kind of ignition system, starting from the conventional coil ignition, and it has been actually modified to the semiconductor ignition system, and at the end there is what's called the distributorless ignition system, in which we have ignition system for each cylinder. So we have a complete ignition system for each cylinder. You can just try to search this and try actually to provide us a presentation on each of those topics. The case of diesel engine, as we told, this is a self-ignition where the charge is only air, and at the end of compression stroke we inject the fuel, then we can start the combustion. The fuels that can be actually self-ignited, we have the diesel fuel, which is dodecane fuel, C12H26. This is the diesel fuel, characterized actually by a given cetane number. And we have the biodiesel. Biodiesel, يا شباب, is not even close to the composition of the diesel fuel, but its characteristics are very close actually to the diesel fuel. That's why we call it يعني biodiesel. Biodiesel يا شباب is a fuel from renewable sources like editable and non-editable oil. Any oil, even the cooking oil, can be converted to biofuel. There is also a practice to have actually the used cooking oil in the restaurant, hotels, and all of that. We can just take this used oil, we can just purify it, and then we can just take this oil and apply the transesterification process, which is a chemical process reaction of this oil and with methanol or ethanol in the presence of catalyst. Then we can produce actually methyl ester, which we call it as the biodiesel, which has characteristics very close to the diesel fuel, plus some glycerin as a byproduct. Glycerin, which is used in the soup. So that's why actually we call it a shabab biofuel. Why we call it bio? Because actually this is biodegradable fuel. Due to the combustion of this fuel, it consists also of carbon plus hydrogen. It can create due to combustion carbon dioxide, but this carbon dioxide can be absorbed by the plant in the photosynthesis process. Unlike the case of fossil fuel, when we are burning fossil fuel and produce carbon dioxide, this carbon dioxide cannot be absorbed by the plant in the photosynthesis process because it is not biodegradable. It is not from a renewable source. So in this case, for the biofuel, the emitted carbon dioxide can be absorbed by the plant in the photosynthesis process, in which the plants take CO2 and it gives us actually pure oxygen in this case. So this is a biofuel from renewable source. Also, it can be a shabab from, this is editable oil, which we can use in our food. There are some other kind of dirty oil, or we cannot say any dirty. It is like the Jatropha oil. Jatropha is a kind of a tree. It looks like olive or something, but this Jatropha, it can be irrigated on salty water, and it can be actually, it can grow actually in desert. And under severe situation, actually, this Jatropha can just grow up, and it can provide actually the Jatropha oil. It is non-editable oil. We cannot use actually in cooking or in our life. But just we can use this oil, apply the transesterification process, simple chemical process, then we can convert it to biodiesel fuel. Many countries should have supported this kind of fuel because it is biodegradable from renewable sources. However, yani, mashallah, oil is flooding here, but yani, this is a kind of, you can have your own startup or something if you like, just to have actually a kind of a factory to just produce biodiesel, a small factory or something. As a matter of fact, Shabab, we have here a unit in the heat engine lab. We have a unit to produce biofuel. It's a simple unit. We use oil, cooking oil. We just purify it, and then we add it to methanol in a certain reaction, and in the presence of catalyst, then we can provide actually generate the biofuel in this case. You can look at actually its visibility and if it could be applied here in a country like Saudi Arabia. Okay. Next time, inshallah, we'll continue. We'll see actually the main difference between the spark ignition engine and the compression ignition engine, or what we call the gasoline engine and the diesel engine. Okay.